Hi everyone, this is lecture series 5 Computer Networks Lab. In this video, we will be seeing about the next experiment, that is the experiment 5. Please be stay tuned for more information. And the first experiment, second, third and fourth is already seen in the other series of video. Now you will be seeing the fifth experiment, that is one last experiment in your part A. So this is nothing but implementation of ESS with transmission node in wireless LAN and obtain the performance parameters. So you're going to implement an ESS. What is ESS? How you're going to implement it with a transmission node in a wireless way? All those you will be seeing. How it is programmed, you will be seeing. So coming inside the program, now here you can see set ns new simulator. This is trace file. So as I have already told, you will create a class object operator where simulator will be created in a terminal to start typing your data to set all the nodes and the transmission links. You will be having two things. One is trace file and one is nam file. So in all the programs, you are just creating the trace file and the nam file. Here in this program, you're going to set a topography. That is, see, actually before going inside the program, all these words are very common for you. Transmission nodes, yes, you will have different nodes which is transmitted from one end to the other end. You will have wireless LAN, that is a LAN that is connected without any wired connection. It is not connected through any cable. It is wirelessly connected. So what is ESS? ESS is nothing but you will call it as extended service set. Like ESS is nothing but, see, this is the laptop that I am using. Okay, so each of the laptop will have an SSID number. Like you will be learning in data link layer, you will have a local address and IP address, so that the data transmitted from one end to the other end will own its own address, so that the receiver will come to know what data is being transmitted actually, right? So likewise, ESS is called as extended service set. It is a kind of ID that is being transmitted through the nodes along with the data packets. So further, you're creating a new topography. Because yes, here it is wireless LAN, you're going to create a grid. That is, the nodes doesn't know where it is to be placed. You are going to fix the nodes where it has to be placed. So you're creating all these, and this wireless 1300, these are all nothing but the network grid, X, Y, Z plot. You will be plotting the nodes. For that, you're including one more line like this when you're creating the animation file. So now coming to the next one, here you're configuring the node. So as I told you, as a laptop is having an SSID number, you're configuring that number. See, whenever you're connecting your laptop to a particular Wi-Fi and searching something in the Google, so your SSID number is being identified by the Google to reply back to you. So you have to create a configuration which is ad hoc routing DSDV. So here DSDV is nothing but it is destination sequence distance vector. What is DSDV? It is destination sequence distance vector. So what is the distance vector? What it is actually? It is nothing but it is a routing algorithm. That is why it is called as ad hoc routing DSDV. So you're creating a distance, you're creating a vector, and you're going to give a routing algorithm for that vector so that the nodes can transmit wirelessly. Okay, so as you have already seen, data link layer will have two sub layers, nothing but your MAC layer and the LLC layer. So you will be giving what type of LL layer you are using, what type of MAC layer you are using. And here you can see IFQ. Here IFQ is nothing but the interface queue. You are setting a queue. How, what kind of queue it is? Drop tile. So you will be setting a type of queue. That is why it is called as interface queue. And you will be setting a channel. What type of channel? It is a wireless channel. And you will be setting the propagation. How the propagation of of the packets will be between the nodes. So two-way ground, that is two-way communication will take place. After that, you will be setting antenna type, ant type antenna, omni antenna. Omni antenna, see, you have unidirectional antenna, bidirectional antenna, unicast antenna, multicast, broadcast. So omni antenna is nothing but the antenna will rotate, keep on rotating 360-degree. If it is a bidirectional, then it is 90-degree, 90-degree. Likewise, omni antenna is nothing but 360-degree. It keeps on rotating the nodes, putting inside the loop. And you will be determining the length of that particular loop. Here, what is the physical topology? Wireless. Okay, so now you have defined the topology. Now you are going to that is, you are going to activate the trace and the activate the agent and the router. Now you are going to click on the agent that is going to communicate, that is different nodes, and the router through which link it is going to transmit the packets. So here you are create God 3. Generally you will just set the number of nodes required, but here you have one extra line called as create God 3. God 3 is nothing but general operation director. It is going to direct the nodes in which way it should move, or in which way the node should be situated. So you will give the general operation director, then set the nodes, and then you will be labeling. ESS should be there, and mob 1 and mob 2 is nothing but the different location where the nodes has to be, like it is a source and destination. You can give any name, like source, destination also you can give it as a name. And here you have set x10. It means that for node 0, the x-axis will be at 10.10. Node 0, y-axis will be 600. For node 0, z-axis will be 0. So for that, likewise, you will be setting x, y, z axis values for each of the node. Node 0, node 1, node 2, you will be keep on setting it. After setting all these, what you will do is, at this point of time 0.1, your node will be in this data destination, that is, it is set to that particular destination where it has to reach. And this node 1 should reach to this particular destination, x-axis, y-axis, z-axis. So the packets start moving from their node to the other destination. And next, TCP. So obviously you will be creating an agent called TCP or UDP. Here I am using TCP as a new agent. You're going to attach all the TCP, that is TCP, to each of the nodes, and you will be creating the file transfer protocols to ensure that this TCP protocol is being followed to transfer the files from one node to the other node. So all these will be done here. And now TCP1 for the other node that you will be creating, and FTP for that particular node will be created. Likewise, you will be creating for all the other nodes, and you are setting start and stop point, where it should start, where it should stop, which node has to start, which node has to stop. All those you will be determining with this destination and source point. And finally, you will be finishing the particular complete program, that is execution will be done. Trace file will be executed, that is all these datas are flushed into the trace to create the NAM file. And finally, you will come into exit, that is the complete data will be finished. Now output, as I have already explained in other series of video, the same procedure will be followed to see the complete data. Here you will not get any like you will get a performance rate how it is, but then more of the performance rate you will be seeing the animation file rather than seeing the output in a word format or in a data format. You will be seeing in the NAM file how each of the packet is routed from source to the destination. That is what we are seeing more. It is focusing more on that routing algorithm. That is what you will be seeing in the animation file. Hope you have understood this program, which is little bit different from the other experiments. Please be stay tuned for more information. Thank you.